Trailing cables are our core part of your day. They're our lifeblood.
Trailing cables are used in the mining process, for example, shovels, draglines, high voltage pumps and electrical overburden drills.
The purpose of this video is twofold. One, to raise awareness on the hazards and risks associated with trailing cable. Two, to provide context on why we need to change how we work around and think about trailing cable. Trailing cable provides vital energy to our largest machines, our draglines and rope shovels. If we use and treat trailing cable with the respect it deserves, the asset can last for over 20 years. However, if we mistreat trailing cable, it creates major safety risks, harms productivity, and adds needless cost to the organization.
We actually had the most amount of cable incidents within the Bowen Basin, which raised also the level of awareness from external parties, being the Mines Inspectorate as well. How we work with these cables is our licence to operate these machines at site. When I'd get the phone call at 1 o'clock in the morning saying, "Damn, we've run over another cable," my first thoughts are, is one of our coal mine workers seriously injured or worse? We just have to stop and take five and treat these cables with the respect they deserve.
To date, whilst we haven't had any trailing cable damage that has resulted to coal mine worker injury, it really is critical to remember that the recurrence of these incidents increases the probability of injury to our workmates.
So we have had a lot of events as well where we've had an unplanned release of energy from our electrical cables of a stationary cable sitting there with no one around.
In my opinion, key to the prevention of avoidable damage is a raised level of awareness.
Now through this video you'll see the energies released from these cables, so have a think about it yourself from a personal perspective. When I hit a cable and I walk away and leave it there, am I exposing my mates to an unacceptable level of risk? Will I be able to go home and sleep comfortably if one of my workmates is injured and I've walked past this and done nothing about it?
In front of me here is an example of a sling which has been single choked around a cable. The reason this is considered bad practice is because it reduces the surface area in which the sling grips the cable, therefore increasing the potential of degloving the cable. Degloving is a term used to describe when the outer insulation of the cable has been stripped and has exposed the live conductors and caused potential of serious harm if the power supply hasn't been interrupted.
Here we have a cable that's been involved in a recent incident for a large electric shovel. It's had an incident where two cables have rubbed over each other and it's compromised the outer sheathing. So this cable will need to get sent off site to get repaired, and at that repair point, the flexibility of the repair and the cable is now compromised and will be no longer like a new cable. Here we have samples from two dragline cables that have been involved in the same incident. It's a HPI on site. It's had a release of energy in 3 different spots. This cable has had a release of energy along here, and then this cable along there. This cable here had come back from a repair, and it's released the energy on either side of that repair. And this cable here was a very good cable, and it's also had a release of energy. In this particular incident, these cables have been set up very well. It was static in nature, and nobody was at the scene or moving the cable at the time of the incident, and we still had an uncontrolled release of energy. So potentially this cable has been mishandled in the past, causing this premature wear today. As a site safety and health representative, this concerns me that we have hidden hazards. Uncontrolled energy can occur at any time, as we've seen here with this cable. So what we do today can affect what happens tomorrow.
In my cable shop role, I've seen a multitude of cable damages. The range of damage is wide, and some cables are to the point where they have to be destroyed and sold for scrap.
Most investigations that I've been involved with, usually the outcome is that people have taken a shortcut or haven't followed safe procedures.
When you're working with the cables, we've got safe work instructions and that in place that are designed to set the guidelines out for the safe moving of cables. And that's there to not only protect the cable, but also to protect you as a worker.
However, complacency does creep in, and electricity is an unseen danger and rarely gives any warning that an accident or incident is about to occur.
I think the leading cause of the incidents we're having is the amount of interaction we're having with the cable and the amount of cable movement that we are experiencing at the moment. It's unprecedented.
Yeah, so we've gone from a one-person horsepower, per se, to 110 horsepower tractors to manipulate the cable around, and some people don't understand, what that cable can manage and handle, so they've overstressed it, where they should take it in smaller, bite-sized chunks.
Often people just mistreat it because they're just trying to get the job done. They think, oh, well, instead of pulling a 20-metre loop, I'll pull a 60-metre loop, or not much thought goes into what's happening in the future.
So we're seeing compression injuries, penetrations from dragging cables across rock, immersion of cables in low-lying areas, places that haven't been correctly set up, trailing cable plugs sitting down in water, the re-energisation of cables after they've been in water, and we've seen some consequence to that with the destruction of trailing cable plugs.
The safety devices, they're the things that are engineered to protect us from electrical discharge from the cable, but at the end of the day, I don't believe that they're the things that we should be leaning on for our own protection. I think the safe behaviours around the cable is what we should be firstly and foremostly promoting. We've got an example here of a cable that's had a compression damage, and you can see the damage. It's gone phase to phase. These conductors are open, and catastrophic failure of the cable. Here we've got an actual piece of a dozer track that's been involved with interaction with the cable. You'll notice there that there's been a piece basically melted out of that grouser from that track. In the blink of an eye, that's something that would take you 30 seconds to do with oxy-cutting equipment. There's another example here, and the energy's actually burnt a hole in the metal. You can only imagine what that release of energy could do to a human body.
I was involved in an incident at Caval Ridge when I was operating a bulldozer and was taking it up the side of the trailing cable, and I lost sight of it. I shifted the blade controller so I could see underneath the draft arm, and I still couldn't see the trailing cable. I then stopped and looked around and saw the lights on the dragline weren't working and thought, oh shit. So I had this terrible sinking feeling in my stomach of the realisation of what I had done and the thought that I'd loaded my workmates up with an extra 8 hours of installation and deinstalling of cable in 40-degree heat. I moved the bulldozer off the cable and got out and had an inspection of the cable and noticed that I'd had 5 grouser marks on the cable, and you could see the phase wires inside. So the damage was immediate. It's something that happens really quickly. You can't actually feel it in the bulldozer. You just, 1 minute you're there and you're backing back in second gear, full noise, and if you sort of look away or look over your shoulder a little bit one way and don't keep that focus on that cable, before you know it, you're over it. I am an experienced operator, but for a moment I didn't keep my eye on the cable, and this is what happens. So I stuffed up. Instead of assuming where the cable is, I should have known where the cable is.
Yes, over the years I have been involved in incidents where electricians have injured backs and knees. We had one electrician who was off work for around about 18 months with a knee which had to be operated on, and he had to do rehab and then return to work. We've also had electricians who have hurt their backs as they have to enter inside the dragline tubs, which is a confined space area, and a lot of manual handling issues. So we have had electricians who have hurt their backs through trailing cable incidents.
This cable here was submerged in water, and what's happened over a period of time is water's worked in through some previous damage into the into the middle of the cable and caused it to explode, and you can see the result of that on the side of the cable there. As you can see here, the cutaway section of this cable, it was underwater, so it doesn't take much of a cut or abrasion or something there to damage that or bruise, and to allow the water into those wires there. The other thing that can happen is the cable may have some damage, and if it's immersed in water, the water can get into the sheaves here, and it may not cause a problem at the time, but later on, just through moving the cable, and it'll actually work its way in further, causing a failure of the cable.
I think the big thing people don't see is the amount of man hours that are consumed behind closed doors to facilitate ICAMs, work their way through investigations, and get them to the end point. Takes a lot of time and pulls a lot of people away from their core roles, where they could be out doing something better for the greater of the mine.
Nobody comes to work to intentionally damage trailing cables. However, after every incident on site, people often wish they'd done something differently.
So in relation to trailing cables, a high potential incident is when we have a release of the energy that's within that cable. So with some of those delays, those high potential incident delays, they can be anywhere from 12 hours to 36 hours delay waiting to get the machine powered back up with the new cable fitted to it, depending on what the nature of the incident is and what equipment's been involved in that incident.
Investigations are important to flush out preventive actions and to stop repeat incidents.
So here in front of us we have a cable handling device. It's a cable grab. It's utilised for, this one is specifically designed for shovel cable, 120mm width cable. It's obviously built to specifications to allow for the right curve radius in the cable so that we don't have any compression of cable. Key features, obviously the handle piece here for the ergonomics for the operator to pick up the piece and utilise it and lay it down within the cable. The front end of it here is for clamping onto the cable. It'll only put so much pressure on. It's hooked to a sling which we tie off to the tractor or the sled vehicle, whichever we're manipulating the cable with. In the handle here, the engineering design has been that this will be the shear point, so when extreme stresses or getting close to extreme stresses are applied to the cable, this will be the fail-safe. Instead of having a shear pin, it's just designed as a weak link. So this is where it'll release and take the pressure off the cable, allow the sling to go through, and you'll see the deflection and understand that you've over-tensioned the cable.
I think most people don't realize how fragile that big, thick cable is. It looks thick when you look at it from a meter away or 2 meters away, but when you put it in that big pit, between that big equipment, most people do not realize how fragile it really is. It's not a robust piece of gear.
In my role as a dragline operator, or any operator, you'll find that handling cable is a big part of the job. We're responsible really for our cable from the sub right down to the dragline. So that means regular inspection of a daily inspection of that cable to ensure that everything is in place at the witches hats on the cable, that nobody has driven over the cable or damaged it or moved it from the previous shift.
I have 35 years experience working with trailing cables. I've seen a lot of damage done to cables over those years, and I would like to see less damage done to cables.
Using the latest technology and fit-for-purpose equipment actually improves the longevity of the cable. It's a lot easier on the cable, therefore it's not putting that cable under duress, so the cable lasts longer.
Still the human factor that contributes to the damage. You know, how a person manages that cable through the day. We've got all the tools, but there's still the human element there. So we need to share the knowledge and understanding of what's within cable to enlighten that awareness to how we manage the cable.
Trailing cables consist of a few different layers of rubber insulation material. My example is the outer sheath here is a rubber material of a compound that makes it strong and durable. Then we have other rubber insulated materials on an earth in this case, a pilot in this case in the centre of the cable, and your actual power carrying conductor. In BMA, what we use mostly in the mining industry are 3 types of cables. The type 409 you see in front of us here, the type 441, and the one absent from the table currently is the type 450. The main difference between the type 450 cable and the 409 and 441 is that the 450 cable is more durable, it's lighter for man handling, and is fit for purpose.
I know that cables can easily last 20 years if they're cared for correctly, use appropriate tools to handle them and stored correctly. It's better to use this technology that we have available to us rather than cut corners and grab slings, example. It saves a lot on the cable, and it also makes it easier for people.
I suppose to put it into context, in the early days it was down to manipulating it with just hemp rope and Toyotas. Today now we have cable tractors with multiple implements to manage cable, so cable forks, jibs, cable reelers on the back end of them. We have cable grabs, cable crooks to allow us to pick cable up off the ground, web slings, myriad of tools and development in the space of cable towers and cable boats that exceeds what we had in the early days.
So the 6.6 kV that flows through these trailing cables is a significant voltage at those Ka ratings, able to melt copper in the blink of an eye.
Would be in comparison mathematically to 27 times the voltage that your house is supplied with.
The old saying, one flash and you're ash, may well become a reality if we do not treat cables with the respect that they deserve.
In front of me is an example of a cable which has been dragged over sharp rocks. You can see on the rocks here that there's copper that has been expelled from the cable embedded in there. Temperatures have exceeded over 2,000 degrees for this to occur. During this process, rocks have also been projected from the bench in the area. So all coal mine workers need to be aware that stretching the cable or putting pressure on the cable could cause hidden damages which may result in an incident or injury to a fellow coal mine worker in the future. I really want them to be aware of the positioning and where the trailing cable is, because too many incidents occur by people not paying close enough attention to where their work area is and where the cable is.
So the trailing cable damage not only affects the safety of our people, but it also affects the business with regards to our draglines and shovels uncover our overburden to expose coal, which at the end of the day, that's our money-making business, which is putting coal through the coal plants, putting coals on the train. So the trailing cable damage does lead to far greater business effects other than safety.
But if you want to have a guidance of what that looks like, you need to have a look typically at Blackwater. Blackwater is running 7 draglines. So if we lose a dragline, we lose a seventh of the capacity of that mine to open up coal. You go to a place like Daunia, which has got 1 shovel. We lose that shovel, we lose the major capacity of that site to uncover coal for that wash plant. You go to Cavill, we run 3 draglines there. We lose a dragline, we lose a third of the uncovering potential of the draglines. So it's significant. And it's significant because of the size of these machines we run downstream. So dollar impact is difficult, I think, to imagine. But if you look at any one of these coal washing plants and you have a look at what feeds them, it gets down to that earth-moving equipment. It ultimately hits the bottom line of profit.
Unscheduled maintenance can cause issues to the supervisor with regards to plan work. So when we have our plan for the week and unscheduled maintenance go up, the supervisor then has to make a call of what work he completes and what work he pushes out. The work that gets pushed out can often snowball, which means we may not get back to that work for approximately 6 weeks with a dragline or a shovel on planned maintenance activities, which can lead to reliability issues, which causes us extra downtime.
I think most of the unplanned events we would have would be around damage. We do not plan to have damage as part of our planning process as well. We do view that we've got highly professional people, systems and processes to help us get through that.
The shovel itself is probably around $1,500 an hour. The fleet of trucks going with that shovel could lead into $10,000 an hour or more for that machine. For a dragline, we would look at around about $2,500 to $3,000 an hour for that machine to be down, just in productivity. And then we then lead into people's wages, etc. So it can be quite expensive when we do have trailing cable downtime through poor practices.
The safe site is a productive site, and we've seen this right across BHP as a business. We've seen this in BMA many times, and every one of our single mine sites, if you go and have a look at the examples today, you'll see that those departments and those areas that's very safe are very successful.
One of the lesser known facts around trailing cable is the time frame associated with its construction. The period between purchase order and delivery of the cable is typically 16 to 20 weeks. These cables are critical to the safe, productive, cost-efficient running of our business, but they are extremely expensive and are a very long lead item. Whilst trailing cable repairs are a quicker turnaround, maybe a week to 2, from damage to repair and replacement back to site, the replacement of a cable wholesale can be anywhere from 4 to 5 months. In this time, the asset is forced to utilise cables of lesser quality or is required to amend the mining plan to suit.
Trail cable damage from a financial perspective is around about $100,000 for a cable and about $20,000 per repair.
So correct handling of high voltage cables will ensure that not only do we get cost efficiency through increased machinery availability, but it also ensures less cost for repairing of high voltage cables.
Well, this is a typical example of a plug that is blown due to over-tensioning. As you can see, the whole plug's come apart. It's been blown apart, which has not only caused damage to the plug, but also potential damage or injury to a person that is standing near it.
We've eliminated partial discharge in the coupler to less values than what you would have on your mobile phone. We've eliminated all the air inside the coupler so there can be no causes of corona or ingress of moisture. And then the other area that we're continually developing is to overcome the handling on the mine sites as well. So we make the faces of the couplers stronger and thicker. We've improved the glands, we've added handles, the shape of the coupler is more easy to manhandle from a site perspective. The most important thing to be looking at when we're moving a cable, especially the ones in around the dragline where we have to move these plugs, is that the plug needs to be secured to a sled or a torpedo or whatever device you have at your mine site. The idea is to secure the plug so it doesn't over-tension, and to follow your safe work instructions regarding moving live plugs.
So I think the biggest thing we can change is handling practices, and handling practices is about knowledge and about behaviour. If we've got knowledge about what is the maximum radius or minimum radius we can bend a cable through, people will make sure that we do not take it through that minimum radius and damage the cable inherently inside. If we ensure that our planning processes are correct and people think what we're doing while we're in the pit, we will not tram with a D11 dozer over a cable. This happens very easily, unintentionally, but the unintentional act and behaviour has got a massive consequence down the line for the organisation and other people.
Some of the key ways that I see we can continue to improve in our dealings with trailing cables is raise our level of awareness within the workforce and ensure people understand the potential consequences, cost and production impacts involved with working with high voltage trailing cables.
Through raising that level of increased awareness, we have outcomes that help us to better manage our trailing cables, to better source our trailing cables, better types, better equipment, better bottom line.
The trailing cables are a key to operating an electric dragline or an electric shovel. I suppose the focus now is on actually assisting the operators to do their job more efficiently by giving them more information on how their trailing cables work and how they operate, so they can actually understand and they will be safer and more efficient in the future.
My first concern is obviously my team members. That's what really gets me emotionally challenged, I suppose. I want to make sure that every day my team goes to work, they don't get hurt. And I really focus on reducing the likelihood of an incident, and I need my team to be engaged with me to make sure that we don't put ourselves in those positions.
We need to get it out there. We need everybody. It's not just one person that's going to make the change, but everyone needs to be together to make the change.
I think safety is free, so use it. and we want everybody to go home, same condition they arrived at work. There's more to life than work, so we want you to go home safe, uninjured, ready for your days off.
Please recognise the energies that are within these cables. Please utilise fit-for-purpose equipment where it's available, and if it isn't available, please speak up. Please treat these cables consistent with their importance to both our livelihood and our well-being.
The underlying message is that this electricity has got the potential to kill.
Treat the cable with the respect it deserves. Don't take shortcuts, and don't rush into things that may seem urgent. And if you're unsure about a cable handling method or technique, stop and ask.
If you do know something, you have an obligation to share. If you don't know something, you also have an obligation to ask.
It might be one of your workmates that's going to handle this cable next, but go further than that and think, what if one of my family members had to handle this cable? What if my wife or my daughter or my son had to handle this cable next? How would you treat that cable with that in mind? And that's the way we need to treat our cables.
Whether you've been in the mining industry for 35 days or 35 years, whether you're working in the mine or working at home on some of your projects at home, please remember, you only get one chance with electricity.
My ask of you is as follows. 1, if you don't need to be around trailing cable, please don't go near it. 2, if you do need to be around trailing cable, treat it with respect, using the right tools and procedures to limit damage. If for some reason the cable is damaged while you are working with it, please report it. This is critical for our safety and the organization. Thanks, and stay safe.